All right, welcome. Welcome to another math video, you rock stars. Today, the goal is to talk about the effects on mean, median, and mode when the data changes, which means sometimes a new piece of data may show up or an old piece of data may be taken out or, I don't know, data changes. It's very thrilling. Hey, what has four wheels and flies? A garbage truck. Garbage trucks don't fly. Oh, they have flies. Bzzz. Oh. Yummy flies. All right, so lesson target. Today we're going to determine the effects on the measure of center. And what are three words that we use a lot when we're talking about measure of center? We're talking about mean, median, and mode. And we're going to talk about when data is added or data is removed or data is changed. Okay, we're going to give a couple examples of those as we go throughout. So if you don't have a strong understanding of mean, median, and mode, make sure you check out that video first, although you'll see some of it reviewed here. But again, we're talking about how data will change, how new data or old data shifted will change our measures of middle, okay? So we're going to review some of the ways to measure the middle of data and then how that data impacts the middle. So mean, median, and mode are the most common ways. Mean, what does it mean? It's the calculated average of data, which means we take the data and we figure out how many, we add it all up, and then we divide it by the number of value points. Now, there's a better understanding of that if you watch the video on balance point, so you can get a more conceptual look at what mean actually means. That's such a weird thing to say. But yes, that's what mean is. It's a calculated average. A median is the middle of the sorted data. And I like to always point out that you have to sort the data from smallest to largest. And then you find that number or numbers that are in the middle, and that becomes your median. Okay? And then finally, mode is the simplest one. You just look at your data and say which piece of data shows up the most. Okay? So that's your review. Let's go. Now, sometimes the data we collect and use happens to change. For example, in grades, you may take a test and the teacher lets you do a retest. You got a 71 in the first one, you do a retest, and all of a sudden you have an 85. That's going to change your measure of middle. That's going to change your score in that class. So we have to figure out how that works. Sometimes data collection was flawed. All right, so people collected data, and then when they got back and they were working on their research, they realized, well, one of these pieces doesn't make sense. Let's go back and look and see if we messed this up. And they find out the data was wrong, so they had to change the data or eliminate the data. When the data shifts, which means eliminated, added, or altered, it changes. Sometimes it changes the measure of the middle. So let's investigate some of those changes. All right, first of all, to explore the data, let's use a scenario to help understand this. And it's the same scenario I've been using for all of the mean, median, and mode videos, which is we have 7 houses that we collected information on, how many episodes they watch per month. And this is the data they gave us. All right. 7 houses all gave us data, how many episodes they watch of Netflix per month. There it is. Okay. So now let's look at a change. So here's the original data in the list that you just saw from the previous slide. Okay, we calculated that average or mean of the set of numbers, which means we added up all the numbers, got 72. We divided that by the number of values, which was 7. And we ended up getting our mean for this situation is 10.2857. Okay, so this data showed us that the mean was 10.2857. Coolio? All right, so now what happens here? There's a plot twist. House number 4 lied to us and they actually watched 13 episodes. So now, how does that impact the mean? Well, we have to go change that data point to 13. Okay. New data goes up and above the original mean. So our original mean was 10. All right. We changed the data by adding 13, which means we just took the data and made it higher than the mean. So when that new data goes up, all right, we would calculate the new mean. All right, so we would calculate the new mean. Here's the original data. All right, we found the mean. Here's the new data. We changed that 8 to a 13, and then we find the data again, or we find the mean again. Add up all your numbers, and now our total is 77. And we divide that by the number of data points we have, which is 7. All right, and what do we get? 11. Our new average is 11. Our new mean is 11. Our new balance point is 11, right? So that means if the data goes up, if we change or add a data point that makes the data go above the original mean, then the mean's going to go up. So We went from 8 to 13, which means it goes up. So our mean went from 10.2, it went up to 11. So altering the data and making it larger would make the mean go up. Altering the data and making the data smaller will make the mean go down. Eliminating a piece of data, so let's just say we got rid of that 8. Well, that 8 was going to be, that was part of, the 8 was smaller than 10. So by eliminating that, it's probably going to make it do the opposite, go up, because we got rid of a small number, okay? So let's look at the median. Here's our original set of data on a list. All right, we sort it first. Always sort when you're doing the median. All right, and there we go, pretty. And so what's the middle of that data point? Because that's what the median is, it's 10. So our original median was 10. Are you telling me there's a plot twist? Yes, House 8 watched 9 episodes. Wait a second. So what will this affect on the median, okay? It really depends on where that number fits into the sorted data. So this one's a little bit different. It may not change things that much, but it depends on where it fits into the data. So left, if the new data point fits in here, it's left of it, it's possible that it's going to bring the median down. And if it's right of it, it's possible that it's going to bring the median up. Well, let's see what happens, all right? So here's our data, original data. The original data gave us a median of 10, okay? And so we got a new data point, which says we need to insert a 9. All right, so we need to insert a 9 right in where it goes. So here's a new one. Now we have 2 9s. All right, and where's the middle of the new data? Well, we got 2 pieces of data. When you have 2 pieces of data in the middle, you have to find the mean or the average of those 2. You add them up. What is 19? What is 9 plus 19? Okay, we get 19. How many data points? 2. So we divide that number by 2 and we get 9.5. So our updated median is 9.5. Okay, so because it was left of the original median, it brought the value down. Not by a lot, but it did bring it down. We went from 10 to 9.5. All right, now let's see what it does to the mode. All right, mode's always the simplest one, right? So we have this data list, same as before. Mode is the number that appears the most, all right? So which is 12, okay? And in this situation, that's our original mode. In this situation, I bet we have a plot twist. Yep, two houses. Gosh. People with their just not giving us the right data. They called and they sent us the wrong data. House 2 actually had 8 episodes, and House 6 actually had 14 episodes. All right. So what does that mean? We changed those data points. All right. So we changed that 10 to an 8 because they said 10, but they actually watched 8. We changed that 12 to 14 because they said 12 and they actually watched 14. And now here's our new collection of data. All right. So what number appears the most now? 8 does. Okay, 8 appears the most. Now, it doesn't matter. This data doesn't shift things up or down depending on the size of the alterations. It just means there's new data, so we got to look and see which one appears the most. In this situation, it was 8. Okay, fill in the blank time. Okay, so if new data is larger than the current mean, so you already solved something, you figured out the data points, and you figured out, oh, the mean of this is blank, let's say 10. And then a new value comes in, or a change value is larger than that 10, the mean value is going to be increased. Right? If you change the data by making the data larger, the mean will go up with it. Okay, if the change in data shifts the median, depending on whether the new data. So in other words, if I get a new piece of data, altered data, changed data, and how's it going to impact the median? Well, it depends on if the new data is larger or smaller than the current median. So if it's left of the median or right of the median, that'll help dictate if the median's going up or down. Okay, and a change in data, when we say a change in data, that can be what? That can be added data, a new house, deleted data, there was like a score that we just don't want to use anymore, like an outlier that we could eliminate, or altered data. Someone gave us wrong data or we calculated something wrong, we put it in, that's going to change the median, potentially change the mean, median, and mode. All right, so which driver never gets a parking ticket? What driver never gets a parking ticket? Oh, a screwdriver.